Okay, so let's get started about today's session. Today we're gonna talk about the COVID-19 data analytics. Yes, and also I will talk about since the vaccine is also the one of the biggest topic, so I will talk about that one too. Today's topic, weekly news and then corona update, vaccine topics, and then COVID-19 data extraction by Python. So the last one I will introduce about the very new and it's very effective, very useful the library for the Python. So I will introduce this the one. The weekly news. I just do this quickly because we don't have much news for I think 1 week. But this one is Microsoft 1.11 and then Apple and 2.74 and Google 2.0 and Amazon. Basically, it's up and down. Especially for today, I think it's going down. But rest of I think tech is it's almost flat. But however, Dow and the S&P 500 they are reaching to I think they beat another record high. I think last 1 week, so that is good. Well, so then this is the ETF. Yeah, ETF is also slightly it's going well. I think especially. What I checked recently is like many of the GAFAM they are coming back again, whereas the many of the small and then high tech company, but high growth company, they still stay low, and then but overall looks okay. Corona update. So the many of the company, many of the country like the US and then also the Europe, they're improving. But however, this is just 1 week, so so if I go to the next one, so this is thanks to the COVID-19 vaccine, which the many of the now is like one dose, one shot is like this vaccination is almost 40% in US, and the full vaccination is 25% in US. So the vaccination is expanding, and then the daily case is now flat. Although so this is almost the same level as the last summer. And then we're gonna talk about this, how we can get this data from the COVID-19 from the Python. And this is another one. So this is our world in data. So it's getting from that data. And then so if we see from here, 1 week is good, but however, maybe like 1 month or 2 months so. We think just especially for after this year, many of the EU, like for example Germany, Italy, United Kingdom is it's improved a lot, but rest of the other countries, it's still I think it's slightly going up, especially the India, and then also it's not display here, but Brazil is also it's going up now. Okay, so then we're gonna talk about this COVID-19 data analytics, but first we're gonna talk about the vaccine, because like vaccine is nowadays. Now I'm living here in Singapore, and then I'm not sure like many of here people here also living in Singapore. So from this June, I think they will expand this vaccination more to the less than 45 years old people, and people can choose either one of those, like Moderna or Pfizer, based on the place, based on the location. So you can choose either one of them. So far, these two are available in Singapore, but I think most people don't know much about like each of the vaccine. People know about the vaccine itself, but people don't know much about the vaccine what type of the vaccine is still there. So we're gonna talk a little bit about that. Then after that, I will talk about this Python data extraction. COVID-19. Okay, so this is a vaccine development. Mostly, like let's say like chicken pox, it takes 28 years until they approved. Flu, 27 years. HPV, 17 years. Polio, 13 years. Mumps, 4 years. But COVID-19, only this case is very exceptional. It's less than 1 year, 10 months. And then they have like the normally like most of the vaccine is belong to any of these 4 types. One is a live antenna, and then inactivated toxoid, and then recombinant protein, and then this 4 is a type. And then, for example, this MMR vaccine is a weakened virus they are using. And they also, this one is, another one is a dead virus. It's used for the flu vaccine. And then there's another 2 vaccine here. One of the things in the COVID-19 we are using, not this Moderna or Pfizer, but some other company is using this one, the small part of the virus they are using in this. They just cut this spike protein from the COVID-19, and then they just in the research center, like some the research area, they just produce this part of this vaccine, and then eventually they just produce and then inject into our body only part of the virus. And then if they found the part of the virus, then eventually they will attack. And then this vaccine development timeline is normally like discovery development is a lot. It takes a lot of time. The human trial or licensing, manufacturing, the distribution, those are it's like I mentioned before, like this one is 10 months, but before, like more than, of course, 1 year, like few years. And then, yeah, this one is 5 to 10 years. But they just trying to make it shorter. So like many of the process is now it's very short. So why they could do this? They actually introduced a new type of the vaccine, and the one is this mRNA. This blue one is mRNA, and the another one is vector vaccine. So this vector vaccine, this first one, this Moderna and then Pfizer, they are actually utilizing this mRNA. Then second one is this vector vaccine. Vector is what this one means is they just using the adenovirus. That is another different, like it's basically a harmless virus. They are utilizing this as a carrier, and then take put inside of there. We just inject the DNA, and we deliver this DNA via this adenovirus, and then eventually we inject into our body. So that is another one. So this is vector type virus, and then this is mRNA. So mRNA is what is good about mRNA. So leave the task to the human body. For meaning for this is the production. So normally like last 4 type, like I introduced before, that is made from research center, like somewhere, like some research area. So they just produce the dead virus or like inactive virus, and then from there they just by using some egg or something, they just producing. But however, this time they introduced 2 different type of the vaccine, which we just leave the task to the human body. So how they do that? So here we just they just take this messenger RNA, which is this will try to this is a kind of recipe to make a protein, and then based on that, so this mRNA vaccine is they just deliver this the messenger RNA. Then, based on that, they trying to create this spike protein RNA. This is part of the it's same as the COVID-19. The COVID-19 has this spike. They try to produce from this messenger RNA. Then eventually they make they inject this mRNA. Then eventually they produce. They just leave our body to make this spike virus. Then they, our immune system trying to attack it. That's how this mRNA works. So currently, so far, this Pfizer and the Moderna's vaccine they are using, and then 95% of the efficacy, which is very good, and also compared to the vector type of the vaccine, which is Johnson & Johnson and then AstraZeneca, they are using the different this vector type of vaccine. Compared to that, the side effect is not that critical so far. That's what we know from the news. But the defect, like the downside for this mRNA, they have to use like ultra cold temperature, because like this messenger will be it's disbanded so easily without this cold temperature. So that's why they have to have like a very special storage. So the delivery will take time. And also so most of the like developed country, like the Singapore also, the US, many of these country, they have this kind of like a storage, so which is good to maintain. But however, many of the other country, it's not so easy to deliver. Whereas this is I just mentioned, so the AstraZeneca and Johnson & Johnson vaccine, they are using this vector type of the vaccine. And what is good about this is this one is easier to deliver, because like this DNA is more stable compared to the mRNA. mRNA is a messenger. We are just giving the recipe to the cell. Then cell is eventually they will produce the based on the mRNA. But however, what? Okay, so however, so this carrier, so this adenovirus, the vector type of the virus, they need to have this carrier, and in that carrier is currently based on the company, they are using a different type of the virus. But one of the famous one is adenovirus, and they are utilizing this adenovirus, inject this adenovirus into our body, and then they will deliver this DNA. However, if our body realize this adenovirus as a carrier, and then they trying to attack, then eventually if they realize the next time if the adenovirus is coming, they trying to attack faster. So that's why DNA cannot deliver exactly to the cell. So due to that, this effectiveness is getting lower every time we shot. So this is one of the reasons that Johnson & Johnson and AstraZeneca's the vaccine is less effective in the future. Okay, so let's go to the data analytics, data extraction. So today I want to introduce this Cobusier, I don't know how to pronounce this, Cobusier PHY. If you want to know more detail about this, you can go to this document, which is very good. I check about many of the Python library for the COVID-19, but I think this one is the best. Then what they can do, I can show you here. One is we can, like, this is a normal case, right? So we can just get firstly date, right? So the date and also the test, like how many people test, and then confirmed case, recovery case, death, population of the country, and also province, state, the country, region, school closing, working closing, cancel the event. They actually rating each of them based on the area, based on the country. Then also the transportation closing, stay home restriction, internal movement restriction. So they have so many the evaluation for each point, each element, information campaign, testing policy, all of these, they just put as one index, which is this stringency index, which is this. This is a raw data. Okay, so if I just but most of people don't need that many data. So if that is the case, then we can just utilize some of the very basic information, which is this. If I try to get the data from the normal case is this, like confirm infected, fatal, recover, fatal, per, confirmed, per, recover, per, confirmed. They also have this data. Then based on that, we can just get this infected, fatal, recovered. We can also show they actually provide this the plot inside of their library. They also they have many countries supported. Then let's check about the different things. For example, this is a confirmed, infected, fatal, recovery, right? Then yeah, so the average they also have like an average recovery period is currently the 16 days. So like it's check calculating from the infected and then eventually infected and then becoming the recovered case. I think I'm not sure about inside of this calculation. You can check about document if you want. That is average. So this one is 16. Also, they can show about the map infected case. So this is a red one is higher, the blue one is lower. Then which country has more infected case here? The US is a lot, right? India also, the Brazil here. So, and then also if we want to specify, like we want to focus on more one country, then we can know about which state has more case. This one is infected. Of course, like we can change this parameter, infected or recovery or something else. Yes. And then also this is a stringency index, which is which country is more strict, like about I just mentioned here, school closing, work closing, cancel event, gathering restriction. All of this, they just put as one index and then showing here as red one is high, very strict. Yeah, like that. So, and then also I just put Singapore here. PCR test. So like PCR test is a COVID-19 test. Like how many people got the test? I can change, for example, United States. Those states, and then if I do this, so yeah, we can see. I'm not sure about this. The meaning of the test, different test, right? The test, and then confirmed case. And then also we can see the positive rate, like from how many people got the positive from the test. So that is here. So nowadays it's getting higher. This one again is the United States. I can change this country like something else. For example, Yeah, PCR input in, let's see, India. Let me try this, if it works or not. Yeah, okay, it works. So this one is like positive rate, right? So after they got the test, and they're high, very high now. It's very, very high. Likewise, I think Singapore is very low. I'm not sure. Singapore, yeah, it's very low. Okay, so like that. And also, they have the map about the number of the test, like which country has more test, which country is less test. US has a lot, and then Africa, it's very less. This is Spain. Oh, okay, so they also lower. And also, we can also, if we want to specify some particular area, then we can just do this. Yeah. Let me see if I can do the India. Yeah, it takes time maybe. Yeah, sometimes. Okay. I guess it doesn't have enough data. Maybe. I don't know. But anyway, let me see. Japan. Yeah, like this. Okay, so let's go to the next one. PCR layer. PCR. This is the vaccine. So that's vaccine, like how many people got the vaccine, the once and then full. This one full means a second. Since I think Pfizer and the Moderna, we have to shot twice. That's why this one is once and then twice. They have these two column. Let's say if I change this one, United States. Okay, so then if I do this, yeah, like that, then eventually I can see the map too. I think this map I couldn't specify some particular area, but yeah, at least I can see that which country is giving a lot of the vaccination. And then yeah, so although like they are not talking about like which company's vaccine, but they are talking about the generally vaccine, COVID-19 vaccine. So if we see from here, Africa, many of the Africa's country, they don't get any vaccination. But US or China, India, they got a lot. Yeah. And also data loader. Okay, so this is another interesting the data. United case over the is a okay. So this is a normal one, like confirm further recovery, right? But and also this is a new case, right? New case. Yeah, so the new case is like this. Actually, they have behind this library, they have so many features. It's not only the actual data, like how many people got the vaccination, how many people got once, how many people got twice. Not only that, they have like estimation, they have like prediction for the future. They have many these kind of things. Also, one of the things I was interested in was how many people got this one is very interesting. How many people was very suspicious, and then from the suspicious status to the infected. Means like if this one is talking about, I think it was United States. I check about the United States, I think. So yeah, United States. So in case of, for example, in case of the April, like this one is last year's April, was very high, suspicious to the infected. No. What I'm talking about is like if he or she is very suspicious, and then if he or she is contacting with somebody, then that somebody, how much percentage that somebody can get this COVID-19? That is the number of this. And then April was very high, maybe because maybe because like the number of the COVID-19 case was very low, So that's why every time like that one person gather with family, many of this family member got the COVID-19. That's why this one is very high. But now after 2021, it's getting lower and lower. Maybe because like people start wearing mask. Yeah, something like that. So we can know about this number too. Another one is this from the infected to the recovery case, like infected recovery possibility movement. So if this one is high, then it's faster to recover. But this one is lower. That means like from the infected case status to moving from the infected case to the recovery case, it takes more time. So I think how many days they are hospitalized, that is talking about here. So this one, if this one is going to be 0, that would be good. This one is high, that means it's no, it's opposite. If this one is high, that is good. This one is low, it's not good. Then also another one is infected to death. Like how many people after the people who got the infection from the COVID-19, then how many people got eventually he passed away. That is now is very low. If this one is becoming 0, that would be good. But now it's very very close to the 0. Means like we are trying to. I think the hospital people are doing very good job after this April to this year's April. So that we can know from this number. Okay. Then also the death right after she or he got a positive PCR test means like we probably know after he already dead, and then after we check about his the death cause, then eventually they realize that this cause was by the COVID-19. So so this one is again the United States. It's showing the April is very high now. So that means like some people got pass away but didn't know the reason, but then eventually it turned out that is COVID-19. So likewise, they have many more. It's not only this. So if you are interested in, they have, for example, a scenario analysis. They also talk about like how they do that. If you want to know about more, then you can just go check. So far, I think this one is made by some Japanese, the university or somewhere. So that's why, and also they actually utilizing the many of the data. That's why it's very good. To me, I'm using this one for the stock analytics. Include, so one of the things I can do, I can utilize this data is here. For example, I have this COVID-19 stock with a correlation. What I do is basically, this isn't very normal. I just grab the, for example, Dow Jones index, right? Then Dow has like a 30 ticker. Then each of the 30 ticker, I'm just checking about like which one is like each day's percentage up and down. Then eventually I just list and then making the correlation map. What this correlation map is showing is, for example, right, Apple, right? So here Apple versus, for example, which one is good? Yeah, this one, 0.012. Apple versus American Express. So when the Apple is going up, like the price is going up, the American Express is not going down. American Express is going down. Like they have that kind of tendency. I check about that one, how I can do that, because like I have like a whole data of this. I just each day it's the up and down to percentage data, right? I just made that one and put into the data frame, and then eventually from that one data frame like this, right? Then made the correlation, so I can see that. For example, another case is visa. Visa, if this one is lower, that means like inverse correlation. If this one is close to the 1.0, that means like a positive correlation. So if, for example, if I try to find like a positive relation, Apple and Microsoft here, because it's very close. Like Apple is going up, then Microsoft tend to go up too. Same goes to Microsoft. Microsoft also goes up. That means like probably like Apple also going up. Maybe like this is kind of tendency. So I'm trying to find the tendency from here, because like if I know about this tendency, then we can have the hedge. Means like I can reduce the risk. So that's how I use. But again, from there, I tried to bring the Covid-19 data. So the Covid-19 data, if I added this one here, then that means like I can see, like I also see if the Covid-19 is going up that day, then price is going down or going up. I can know about that tendency. So yes. Then how I do that? I just utilize their library. And from their library, I'm just getting this United States data. And we know about this, right? Confirm infected further recovered. 2020 February 9 was only 9 people. Now is 2021. Yesterday, the April 18, it's a lot. Yeah, they recover also a lot too. But then I need to make a new case. So I calculate like confirm like previous day and then today. I just subtract and then I put the new case here. So the new case is here. The new case, I also make the moving average. 3 days moving average. That means that why I do this is because like I can know about the tendency. So I made this moving average. So this is a new case moving average here. Then I can use this PCT change. That means like I can see the percentage, but also basically I'm calculating here. So what I'm seeing here is day by day compared to the previous day, how much percentage the COVID-19 case is increasing or decreasing. So that is a percentage here. Now we adding this one into the correlation map. Then we can know like, but most of the case, what I realized after adding this is most of the case is inverse correlation. Means like if this one is going up, then many of the stock tend to go down. If this COVID-19 tend to go down, it's going down, then many of the stock is going up. But I understand, right? But even there, I still can see, for example, this 3M is, for example, compared to others, slightly positive. Means like even though COVID-19 is going down, still this tend to go up. Still, it's not going down much. Yeah, I can say, I can rephrase like that. So yeah, likewise. So this is one of the usage. Of course, like you can choose like how to use this COVID-19 data. But anyway, so this one is very, very interesting. They also have like machine learning inside here. So they also have the data inside here. So you don't have to use like TensorFlow or something. You can simply purely utilize this library, then you can get the many of the data. So, so that's it for today, I think. Yes. Okay. Otherwise, I think that's it for today. Thank you so much. We'll talk about next week. I will talk about the AI. And then the AI stuff is very another interesting, but scikit-learn first. Then next time I will talk about another different things. Okay, that's it. Thank you.